So I have recently been falling in love with this YouTube channel. It's Cracking the Cryptic, and every day at least one puzzle is uploaded, and these puzzles are very innovative, and it is solved by one of the two resident gurus. This is Simon, the other one is Mark, and they are both brilliant. And today's puzzle was the first one where I achieved a solution that was cleaner than Simon's, which I'm very chuffed about because he is well ahead of the game. My goodness. Try watching a few of his harder solves, which completely confound me. This one is very elegant, so I'm going to try and speed run it. Bear in mind I've already done it a couple of times. So it's not a fair comparison to Simon's solve. The first time it took me about an hour. So let's see if I can improve on it, but the logic should be the same, just less pondering. So let's give it a shot. The first thing I notice about this puzzle is it seems to be begging for a pattern completion, a tiling like this. Even before looking at the rules, this is just shouting out, isn't it? Let's put those in grey. I feel like we should be tiling these dominoes in red, green and blue. And look at this pattern, a red followed by a green, blue. A red followed by, if we cycle, a green, blue. A red followed by a green, blue. It's just shifted once to the right each time. Quick rundown of the rules. We have the black dots are doublers, so 1, 2 would be valid. Also 3, 6 would be valid, etc. There's only 1, 2, 2, 4, 3, 6 and 4, 8. Those are the only possible doubles. We have a grey line that says the amount of the grey line in each box must be the same. So the amount in this box, i.e. that, must equal the amount in this box, i.e. this. So this must equal this. Total. We've got purple line, which is consecutive digits, not necessarily consecutively along the line. So 5, 7, 6 would be perfectly fine. And the white dot is consecutive. So 4, 5 would be valid, but 4, 6 would not. And finally, we've got the diagonals. These add up to 24, and these add up to 16. Notice 16 is a very low number for 6 cells. And the most important rule, well, it's a rule I haven't seen before in one of these puzzles, it's mirroring. It says that these 3 digits, whatever they are, must be the same. And these 3 digits, etc., must be the same. I'm trying to put an X in because I'm pretty sure I can put an X, but it's not having it for some reason. Strange. So like if very strange. Anyway, so that would be valid, for example, but that would not be valid. They have to mirror. Okay, so naively, you'd want to put blue here, because you'd say, well, blue is ruled out of here, here, and here by these 3 respectively. Therefore, blue has to go here. but not so fast, because we don't know that blue and red are disjoint. What if that digit and that digit were the same? Then we would not be able to make that conclusion. But if we could show that these were red, then we would have blue and green are disjoint from that box. We would have green and red are disjoint from that row, and we would have red and blue are disjoint from that column. And I think that will allow us to, in fact I know now, it will allow us to complete the tiling. So the challenge is on to show that this is red. It looks like it could be red because it has the same total as red. So can we do it? How would we go about it? The pattern that's calling out is this one. Which is a well-known trick in these puzzles. So we put all the horizontals into bag A, the numbers 1 through 9 3 times. We put all the verticals into bag B, the numbers 1 through 9 3 times. Clearly, bags A and B contain exactly the same elements. But each of bags A and B contains these 9 numbers, whatever they are to be found in both bags A and B. So we remove them from both bags and the bags remain equal. So the horizontals bag is what? 3 greens plus 3 reds plus 3 12s. That's all divisible by 3. And the vertical bag contains what? 3 blues, a couple of 9s, everything divisible by 3 so far, 3 dots. Now a dot is divisible by 3 because it's a 1 to 2 ratio, so it's 1x to 2x, so it's 3x, where it doesn't matter what x is, the domino is divisible by 3. So 8 out of the 9 dominoes in our vertical bag B are divisible by 3, so therefore the last one must also be divisible by 3, as bag A is divisible by 3. So divisible by 3 is 3, 6 or 9, so this domino must total 3, 6 or 9, but it has a consecutive constraint, which is an odd number and an even number. So 6 can't, an odd number plus an even number is an odd number, so totaling 2 consecutive numbers must give an odd number, so 6 is ruled out. So we've got 3 or 9, and 3 is 1, 2, which looks plausible, and 9 would have to be 4, 5. But this 12 cage here, which is 3, 9, 4, 8 or 5, 7, but not 3, 9, because there's the 9 already there, 4, 8 or 5, 7, if we had a 4, 5 here, it would rule out both 4, 8 and 5, 7, and we would be unable to complete this 12 cage. There's nothing we could put in it. Ergo, this can't be 4, 5. Ergo, it's 1, 2. So 1, 2 totals to 3, and by the grey line constraint, this totals 3. Therefore, this must be 1, 2. Therefore, this must be red. QED, quod erat demonstrandum. That which was to be shown has been shown. So, now we have that red and blue are disjoint. We already had that blue and green were disjoint, and that red and green were disjoint. So red and blue and green are 6 separate digits. So we can do the blue trick. replace blue here. And we can fill out all of these now. I think we can, well, first we should notice that each of these 9 cells sees red, blue, and green. Sees a complete red, green, and blue domino. Just do it by eye. Red, blue, and green. Blue, green, and red. Yes. So these 9 dominoes are not red, not blue, not green. So I'm going to make them yellow. So where does green go down here? It must go here. Where's blue to be found? Here. Red down here. Can't be there. Which puts green here. That's got to be blue. That can't be red. Puts red here. Which puts green here. Fantastic. We have the pattern that we were hunting for. Now, what next? This constraint is calling loudly. Because we know that blue and green have to be minimum 3, 4, because red's already taken 1 and 2. So we'd have to put 3, 4 there and repeat it by the mirroring rule there. And that's 7 and 7, which is 14, which needs a double 1 to make 16. And the mirroring, this 3, 4, well, 3 can't be, blue can't be 3, because blue is 4, 8, or 5, 7. We did that earlier. So these are 4s. And by mirroring, that's a 4 as well, which puts 8 there, which puts 3 there, and by the mirroring rule there. Now green makes 9, so these have to be 6s. Actually, I was going to say, can I do the whole thing without pencil marks, but I've already put 1s and 2s in there, so too late to turn back now. But I do have 1, 2, 3, 6, and 4, 8 for my reds, blues, and greens, which means yellows must be 5, 7, and 9. And 1 is red. I suppose gives us a 2, 1 there, 2, 1 there, 2, 1 there. Do we have some 2, 1 there? We have a mirroring, 1, 2. Where does 2 go? Here, where does our other red go? I'm going to call this the max 2 constraint. We can have a maximum of 2 same colour red, green, blues in any row or column. So a red there or there would violate max 2, because it would be putting, for example, 3 reds in a column or 3 reds in a row. So that's got to be the other red. And this constraint is very useful in this puzzle. So I suppose we can 5, 7, 9 that. For example, green here has to be these 2 cells, because that would cause a max 2 violation. If we were to put the green here, we'd be getting 3 greens, for example. So those are our greens. So now that makes those yellow. And I know I could work with the 9, but I'm going to save that for a bit. I'm trying to do this in minimal movements. Max 2 constraint on this box puts the other red here. Here. What are we left with? We're left with this 24 constraint, which doesn't look actionable yet. This one's the tastiest one, because it's going to peek into this box as well if we can reduce it. So that is 4, 8, and this is 3, 6. So what can this one be? If that's a 4, then we could go 4, 3, 2 is impossible. 3, 4, 5, that's possible. 4, 5, 6 is possible, but 5 again. Or 8, 7, 6. So that's a 5 or a 7, which makes it yellow. So we've got to place 2 blues, and by the max 2 constraint, they're going to have to go there. You can just see if we were to place a blue there, then it's going to cause trouble if we place the other one. So that's a 4, 8, 8, 4, 8, 7, 6 now, which puts 3 there. 1 remaining, so it's a 5 or a 9. Let's take the 7 out there, put 5, 9 there, and make it yellow. What next? Are we close to the 24 now? Maybe we're close enough. Because that 3 gives 6. 6, 3. So there's only one number missing from the 24. So we've got 6, 10, 14, 15, plus 9. Gives us 24. Now we can use another max 2 constraint, because we have to place 2 blues here. They'll have to go there. Which puts that yellow. So now we've got 4 remaining boxes. we're nearly done at this point. So we need 2 yellows and 2 greens, and they're going to have to be in an X shape. We've got a 7 here, and we've got a couple of 9s. Oh, that's giving us the 9 up there. Which this makes things very convenient. It unlocks there. So we've got 7s, putting a 7 there. Seven, 9, that's a 5. And that's not a 9, so it's the 7. That's the 9. 9, 9, 7, puts the 5 there. 9, 7, 5. It's also much easier when it's color coded. 5, 7, 9. That's got to be 9. That's the 7. And now it's very close to being done. We've got 4 boxes. 7, 7 puts the 7 in one of these 2. That's the 7. We can do a max 2 constraint on reds here. Which puts a yellow 5 there. These 2 are surely going to crumble. 7 puts a 5 there. We need a 5 and a 9 here. 5 puts a 5 there. Max 2 constraint, and we've got to fit 2 greens, which are 3 and 6. Puts a 9 there. What are we left with? Maybe that 7's going to help us out here. It does, it puts the 7 here. Now we can max 2 constraint these to blue. Which are 4, 8, and 9 this. And do 9s constrain there. 9, oops. And we max 2 constrain green, giving us yellow, which is 5, and the greens must be 6 and 3. Which places a 6 and a 3, and that is 2 and 1, and that's 8 and 4. Boom. So this is what always amazes me about Simon's channel, is I've run at this puzzle 3 times, and even speedrunning it, I am. Once you remove his intro, my solve time is barely faster. Um, so I don't know how he does it at the speed that he does, but I think this was a clean solution. I very much enjoyed this puzzle, and I recommend the channel. It's a fantastic channel. Over and out.